Hello students, welcome back to TutorHub, your e-classroom on YouTube. So today we'll be solving problems on angles of elevation and depression. So for this particular lesson, I want you to recall what we learned from two previous videos. The first one is on angles of elevation and depression. So I want you to check that out so that you will recall how angles of elevation look like and how angles of depression would look like. Second, I want you to also recall our videos on SOHCAHTOA or the special trigonometric ratios that we discussed previously, SOHCAHTOA. So check those videos out because we will be using them when solving problems related to angles of elevation and depression. But before we proceed, I want you to please click subscribe because we'll be having a lot of videos for you to learn in the coming days. And this will help you track which videos you need to watch. And for sure, this will help you learn a lot in math, chemistry, and whatever subjects we'll be posting here in this channel. And please also like and comment on the videos, okay? So if you understand the videos, if you like it, if you're learning something, please click like and comment below, okay? So without further ado, let us go back to angles of depression and angle of elevation, right? So with respect to the horizontal line, we recall that if this is the horizontal line and if this is your line of sight, right? The angle that moves up with respect to the horizontal line is called the angle of elevation. Very good. But if with respect to your horizontal line, the line of sight goes below it, this will now become the angle of depression. Very good. Okay. So I want you to draw and label the diagram for this particular problem. So we'll be solving some problems here in this particular lesson so that we will use the concepts of SOHCAHTOA, right triangles, the uh, trigonometric ratios, and also angles of depression and elevation to solve certain quantities or sides of a triangle following the principles that we learned in the previous lessons. Okay, so let's read the problem together. So from an airplane at an altitude of 1,200 meters, the angle of depression to a building on the ground measures 28 degrees. Find the distance from the plane to the building. So let's identify the given information first. So there's an airplane at an altitude of 1,200 meters. So altitude, what do you mean by altitude? That's the height, the, the distance of the airplane from the ground. Okay, so you're looking up to the airplane or and then the angle of depression to a building from the airplane is 28 degrees. So the question is find the distance from the plane to the building. Okay, so to help us visualize this problem, we can draw the problem first. Okay, so let's say this is your airplane. Okay, I don't know if I can draw very well. Okay, right, so that's our airplane. And then we have a building, right? Let's draw it somewhere here. So there's a building. Okay. Okay, so let's imagine that that's the building. And the airplane is 1,200 meters high. Okay. And then the angle of depression of the building with respect to the airplane is 28 degrees, right? Okay. So the question would be, how far is the airplane with respect to the building? Okay, let's go back to the previous, to the question. You have the altitude, the height of the building, I mean of the airplane from the ground, and then it is 28 degrees. The angle of depression of the building with respect to the airplane is 28 degrees, and we need to know the distance from the plane to the building. Okay? Distance from the plane to the building. So how do we determine this one? So we want to know x, right? Okay. So the distance of the plane to the building here. Okay. So because of this, we can say that these two angles, the 28 degree here, is equal to the length or to the measure of the angle here, right? Okay, so this is 28 degrees. Do we call this vertical angles? Right? They are congruent angles, right? So because this is also 28 degrees, we can use our trigonometric ratios to determine the length of x, right? So if you notice, this would become a right triangle, and we can establish the relationship or the length of, or we can determine the length of the distance between the airplane and the building, which now is the hypotenuse of the right triangle. Okay, can you see the right triangle here? Okay. Now, which trigonometric ratio should we use so that we can determine the length of the hypotenuse here, or the distance between the airplane and the building? Very good. So if we use sine theta equals opposite over hypotenuse, right? So if we substitute the values, the angle that we have is 28 degrees, right? With respect to this angle, the opposite side is 1,200. So sine theta equals 1,200 meters all over hypotenuse. What's the length of the hypotenuse? That's x, right? We do not know it yet. So theta is 28 degrees, right? So if we solve this problem, we simplify it. Transposing x to the other side, we will have x is equal to 1,200 meters all over sine 28 degrees. Do you follow? Okay, so if we have this now, get your calculators. What is 1,200 meters over sine 28 degrees? Everybody get your calculators and try to solve this. What do you get? Very good. You get 2,556.07 meters. So that's the distance between the building and the airplane. Okay? Is that clear? It's very easy, right? If you understood how the trigonometric ratios work, then you will find these problems very easy. So these are just like real-world application of the 6 trigonometric ratios. Okay? Now let's go to our second problem. Let's read it together. Okay? From a point on the ground, 12 feet from the base of a flagpole, the angle of elevation of the top of the pole measures 53 degrees. How tall is the flagpole? Okay, I want you to read it again and identify the given information. What do you have? Very good. So you have the height of the flagpole, or the distance of the point from the flagpole, which is 12 feet. And then the angle of elevation is 53 degrees. So the height of the flagpole is being asked. So how do we draw that? So it will be good if we draw the problem so we can solve it much easier. Okay, get your notebooks and papers. Let's solve it all together. So if this is the point that we're looking at, okay, the point to the flagpole, okay, is 12 feet. Okay, and the angle of elevation to the flagpole, oops, is 53 degrees, right? So the question is, how tall is the flagpole, right? So with respect to this angle, we are required the opposite side and we are given the adjacent side. Is it correct? Very good. So which trigonometric ratio do we use to solve this problem? Think about it. Very good. We use tangent. Okay, tangent theta equals opposite over adjacent. So our angle theta is 53. So we substitute that tan 53 equals opposite. What's opposite to that? X, we don't know. Over adjacent, that's 12 feet. Okay. So solving for x, we transpose 12 to the other side. So we now get tan 53 times 12 feet is equal to x. Get your calculators. What would be the answer here? X would be, everybody get your calculators. Try to solve the problems. Okay, the problem. Very good. If you multiply these two, x would be 15.92 feet. So that's the height of the flagpole. Did you get that? Very good. Good job, everyone, for getting that. Who got 2 over 2 so far? Very good. Now let's go to our third problem. Okay, so let's read number 3 together. Julia observes a car approaching on the desert plain from her position on top of a 30-meter cliff. The angle of depression of the car at that instant is 47 degrees. How far from the base of the cliff is the car? Okay, let's help Julia determine the distance from the base of the cliff, okay, with respect to the car. So again, we have the given information. We have the height of the cliff, okay, the angle of depression, 47 degrees, and we want to know the distance from the base of the cliff to the car, okay? Now, let's try to visualize a problem. If this is the cliff, that's 30 meters, and Julia is here. Okay, let's draw Julia. And then there's a car, okay? Don't know if I can draw a car very well. Okay, right? And then the angle of depression with respect to the line, to the horizontal line of Julia is 47 degrees, right? Okay, so that's 47 degrees. And we want to know the distance from the cliff to the car. So this is the unknown value. Okay, so this is similar to our first problem. And just a correction, this angle, the 47 degrees, is equal with this angle because this is 47 degrees because these two angles are called interior angles. I stand corrected. It's not vertical angles. They are alternate interior angles because when there are two parallel lines cut by a transversal, it is understood, or within that theorem, the two angles formed by the transversal line with respect to the two parallel lines would be congruent. And we call these two angles the alternate interior angles, and the line that cuts them equally is your transversal line. Okay? Now, so if we look at the triangle has this side, right? And you have this angle, and you don't know the length of x. Okay? So with respect to angle 47 of this triangle, you have the adjacent side and the opposite side. So which trigonometric ratio do we use to solve the length or the distance between the cliff and the car? How do we solve for x? Which trigonometric ratio do you use? Very good. Tangent theta, because it includes opposite over adjacent, right? So theta, tan theta, the theta is 47 degrees. The opposite side is 30 meters. The adjacent side is x. So if we solve for x, transpose it to the other side, x now becomes 30 meters all over tan 47 degrees. Everybody, can you please solve for x? Get your calculators, everyone. Solve for x. What's 30 meters over tan 47 degrees? Very good. X is 27.98 meters. So this is the distance between the cliff and the car. Okay? Very good. Did you all get it? Good job, everyone. Let's move to the next problem. Number 4. Joy is sitting on a treetop 3.5 meters tall, and she observes Fritz the cat on the ground 2 meters from the base of the tree. Calculate the angle of depression from Joy to Fritz. So let's identify the given. You have a 3.5 meter tall tree where Fritz is sitting on, and it's 2 meters from the base of the tree. Okay, there's a cat that's 2 meters away from the base of the tree. Calculate the angle of depression from Joy to Fritz. Okay, let's try to visualize the problem. Okay, so there's a tree and Fritz is there on top of the tree, and there's a cat. Okay, don't know how to draw a cat. Okay, let's say that's a cat. Okay, it's not a mouse. Okay, so Fritz is there, and then the cat and the tree is 2 meters away, and the tree is 3.5 meters tall. Okay, so if this is the line of sight of Fritz, the horizontal line, and this is the line of sight of Fritz, you are asked to determine the angle of depression. Okay, again, this is a transversal line. So these are alternate interior angles. So angle theta here, the angle of depression is equal to the angle here below with respect to the cat, right? So in that case, which trigonometric ratio do we use to solve for theta? Okay, with respect to this angle, we have the adjacent side and the opposite side. So which trigonometric ratio do we need to use, or can we use to conveniently answer for theta? Very good. So still tangent theta is equal to opposite over adjacent. Very good. So solving for that, tangent theta, we don't know theta. Opposite side is 3.5 meters. Adjacent side is 2 meters. So solving that, you have tan theta is equal to 3.5 over 2. So theta equals tangent -1, 3.5 over 2. Everybody get your calculators. What is the value of theta? Tangent -1 or shift tan 3.5 over 2? What answer do you get? Everybody get your calculators. Okay, what did you get? Very good. The answer is actually 60.26 degrees. Did you all get that? Very good, students. Okay. For our last problem, let's read this all together. An airplane pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. What is the airplane's surface distance from the raft? Okay, so this will be your seat work. So everybody get your papers. Try to solve this problem. Okay, so you have 26-degree angle of depression as you're given, and the altitude, the height of the airplane is 3 meters. So what's the surface distance from the raft? Okay, so let's try to visualize a problem. So again, you have an airplane. Okay. Okay, imagine that's an airplane. And then you have a raft. Okay. And then the airplane is 3 kilometers above the ground. And the angle of depression with respect to the horizontal of the airplane is 26 degrees. Okay. Because these are alternate interior angles, so they would have equal measures. So we are asked to get the value of x, the ground distance from the raft to the airplane. Okay? So with respect to this angle, we have the adjacent and opposite. So which trigonometric ratio do we need to use, or do we use at this point? Very good. We use tangent theta equals opposite over hypotenuse. Okay? So our theta is 26. Our opposite side is 3. Our adjacent, opposite over adjacent. Okay? Let's rewrite it. Tan theta is opposite over adjacent. Okay? Please check that properly. So tan theta equals opposite over adjacent. So we have the opposite side, 3 kilometers, the height of the airplane, over, we don't know the adjacent side, x. So that will be the thing that we will solve. So x now, if transpose it here, then and tan 26 below, that's 3 kilometers over tan 26. So what is the value of x? Everybody get your calculators. What did you get for the value of x? Very good. So x equals 6.15 kilometers. Okay. Who got 5 over 5 for our exercise today? Those who got 5 over 5, please like this video. Those who did not get 5 over 5, please comment down below your scores and which part was difficult for you. Don't worry, because this will help you master the concepts. Watch the video again and again so that you'll gain mastery about the topic. So thank you everyone for watching. Please don't forget to subscribe to the channel, like this video, and leave a comment. Thank you everyone. Happy learning everyone, and thank you for watching TutorHub, your e-classroom on YouTube. Bye!